Hi, everybody. Welcome to From Cluster Analysis to Classification, the webinar that Dominique Joye from University of Lausanne will present. Dominique is Professor Emeritus of Sociology at the University of Lausanne. He was chair of the Methodological Committee of ISSP, member of the Executive Committee of EVS, and of the Methodological Advisory Board of ESS. His research interests include survey methodology, social inequalities, and social networks. So right now, I will ask Dominique to share his screen. And he will present to you his presentation, his paper about classification and cluster analysis. Go, Dominique.
Okay, thank you, Claire. Thank you, everyone. I hope that you can see my presentation, or at least the first slide. What I wanted to mention is first, I am a sociologist or a social scientist and not a statistician. So I will really take the point of view of the user and not the point of view of the statistician or the that's important to recall. Second, of course, I am open to all questions. So Claire, you can interrupt me anytime. Otherwise, you can use the chat or the function in order to ask questions in during the presentation. Third, I have chosen to use R for my example, also because I like very much this software. Of course, other software like SPSS and other, you can do the same analysis more or less with other softwares. But I think R is a beautiful tool, and I like it more and more. So I have chosen it for this case. Mostly, where I am. Yes. Mostly from presentation, I will try to present 2 or 3 beginning tools and then to develop a real example and to see how to manage this real example. You will see that from my side, the main difficulty is to choose the good measure, which is much more important than a particular statistical technique. So that's more or less the frame that I want to use. Okay. So the first point, cluster analysis, the definition is rather easy. That's to make groups in the data. So to find that individuals are belonging to a particular group and to find the best way to distinguish groups in the data. That's a very interesting technique because it's easy to communicate. I don't know if you have already tried to explain factor analysis to people. You can do that, but it's not always very easy to understand the concept of latent variables and how to share the idea of latent variables with people, at least for journalists, political people, and so on. So it's rather easy to use a classification. So that's mean to say, okay, we have found different groups in the data, and this group 1 is this one, this group 2 is this one, and so on. And it's rather easy to communicate. So that's a good point of the classification. At the same time, it's a little bit complicated because you have relation between these groups. In fact, typology or cluster, the result of a cluster analysis is a nominal variable. And this nominal variable, you have to explain which category you have and which is the link between this category and the other ones. So we'll see that's one of the problems that we must have in mind is which theoretical system we will use in order to communicate the points to the people. But in fact, if we have the good terminology, that's rather easy to communicate. But there is a lot of choices and technical choices that are really important for the result. And so I will first try to show you these points. The first point is, of course, we'll see that the first point is to choose the good variables in order to do the analysis. and more important, a good way to measure these variables. And we will see this point. Okay? So, as the general context of cluster analysis, that's the idea to reduce information. Everybody knows that we have a lot of variables in our solver, and that a good measure is very often obtained by combination of different measures. So we must find some ways to combine this information. Most often or very often we do that by latent variables. So we replace a set of variables by one or two or three factor or latent variables. But we can do the same in the other direction. So to replace information by just a nominal variable that will take as possible of the original information that we have.
Dominique, I will
Yes.
stop you just 1 minute. Alexander Wilgem raises hand, so I see that I can allow him to speak. So I will see if he wants to ask a question. Alexander? I don't see it. Okay. So look, people, instead of raising your hands, perhaps put your questions in the chat, and I will try to once in a while send a question to Dominique. Okay, thanks. Go on.
Okay, thank you, everybody. Do not hesitate to ask questions and to stop me if I am not clear. So what I wanted also to mention in this introduction that, as you know, we have at least two approaches in statistics or data analysis. One, which is rather exploratory, just we look without too much hypothesis what is going on in the data. And another one, which is more confirmatory. For example, in the case of latent variables, that the difference between principal component analysis or correspondence analysis on the exploratory side and the structural equation models in the confirmatory side. We have more or less the same in cluster analysis but most of the cluster analysis is on the exploratory side. We have also some latent class analysis that allow to be more confirmatory, but I will not speak about this side. I will stay on the exploratory and just to look if there are some structure in the data and how can we find this structure in the data, and from a purely exploratory point of view. That does not mean that there is no theory, because we are not able to look to something without theory, but the main point will be to see the structure in the data rather than to test a model. And this is an important difference. So in most of the topic, we will be on the exploratory side. Okay. So the main point, as mentioned, is in order to reduce information and to explore the structure of the data, we have the geometrical side with the principal component analysis, that is to find some factors, latent variables in the data. And we have the cluster that will try to find a typology, a categorical variable, in order to summarize the data. In fact, what we are doing is really the same as in the basic social position analysis. If I use a socioeconomic index, okay, it will be something like a latent variable, an underlying variable that describes the individuals on the continual interval scale. If I use a class schema, the class schema will be a categorical variable. And you can say to do a cluster analysis is something like to find the class schema in the case of the social position analysis. Of course, when we use a schema, there are always some underlying variables under that. So if I take, for example, the class schema of Eric Colin Wright, I think that most of you probably knows this class schema. Eric Colin Wright was a beautiful sociologist at Wisconsin University. And Its class schema, in fact, distinguish between owners and non-owners of the mean of production. And between the non-owners, there's a distinction between the organizational asset and the skill asset. So in fact, that's a combination of three different dimensions: owner, non-owner, high skill, medium skill, lower skill, and high organizational assets, medium organizational assets, low organizational assets. And the combination of these three dimensions give a categorical variables, in this case with 12 categories, which is the result of this analysis. Of course, it is a conceptual analysis in the case, but more or less to do typology or a classification is to obtain a categorical variable like the class. And from this, we will try to define the different groups, also function of the dimension, the underlying dimension, in order to make sense of the result that we have. Okay? So that's just the magic of the classification. But how to do this magic? That's the technical things. The first point, we will put together objects or individuals or units that are close from each other. So that means that the first thing that we need to have is a definition of the distance between objects. So most often we will just use an Euclidean distance, that the distance that you use every day in order to measure distances between cities, that we use in geography. And that's the classical Euclidean distance. Of course, there is a lot of different distances, but I will not go too much in this direction. But just it's important to know that normally we do the choice to have an Euclidean distance, a geographic distance, if you prefer. And that will be the rule in order to measure the distance between the objects. It could be mentioned that, for example, a correlation coefficient is also a measure of distance, or the inverse of the distance, of similarity rather than dissimilarity. And it is perfectly possible to do some cluster analysis, as other analysis, in fact, just using the correlation coefficient as a measure of distance. That's more or less the same. That means also, and I will go back to this a little bit later, that, okay, the example that I will show to you is distances between individuals, but it's also perfectly possible to make analysis of the distances between variables, just turning the matrix of data, and you can go the analysis in one side or in one direction or the other. And there is no reason not to look for the proximity between variables as we look for proximity between cases most of the time. Okay? So, first of all, we have to define or to find or to compute a measure of distances between objects. That's easy. Now, if we have a matrix of distance between objects, so in this example, I have 5 objects. And that's my first matrix A5. Of course, I will put together the objects that are closest from each other. In this case, it's easy. The 1 and the 2 object, because they have a distance of 2 between them. Okay? Now, so I know that in the first step, I will have to put together the object 1 and the object 2. Okay? So I have a new group, which is the object 1, 2, that I will...
I just stop you, Dominique, because I don't get, and probably people don't get, what is object 1 and object 2, because we have A5, A4, A3, A2.
Yes.
And so we don't know which one is which one.
Okay. So in my first step, I have the matrix A5 with 5 objects. And I have the distances between the 5 objects. Of course, between 1 and 1, it's 0. 1 and 2, it's 2. 1 and 3, it's 3. 1 and 4, it's 7. And 1 and 5 is 9. So my 5 objects are just, it could be cases, it could be big regions in a country, it could be what you want. In this case, it's not important but what is important, I have these 5 objects, and I have computed one distance or a matrix of distance between these 5 objects. Okay? Now, I know that the 2 which are the closest one are 1 and 2 because they have a distance of 2. So I know that I have to put them together. But now I have to compute a new distance between this new object 1, 2 and the other ones. So that's where it's beginning to be a little bit complicated, because you have different ideas to compute the distance between these 2 objects and the others. One technique, which is called single linkage, which is the one here, say, oh, we will take the minimum distance between my 2 objects and the others. So from 1 to 3, I have a distance of 3. For 2 to 3, I have a distance of 4. Which is the smallest of the 2? Oh, that's 3. So my distance from the new object 1, 2 to the old object 3 is 3. Okay? The same. My distance of the object 1 to the object 4 is 7. From the object 2 to the object 4 is 6. So the smallest of these 2 distances is 6. Okay? And so I can compute a new matrix where I have 4 objects and no more 5, because I have 1 or 2 put together. And I have the 3, 4, and 5, which are the second, third, and fourth object in my matrix. Okay? And I can do the same for that, the next step between, so the smallest number in my table here is 3. Between object 1, 2 and object 3, I have a distance of 3. I put them together and do the same and so on. So I have a couple of rules going from 5 objects to the 2 objects. Okay? And I can have, okay, a geometrical representation of that. So my first 2 objects are the 1 and 2 that goes together at level 2. Then the object 3 at level 3, the 4 and 5 at the object 3, and so on. Okay? That's the idea of the single linkage. But of course, you can say, but it's stupid. Why to take the minimum? Why not to take the maximum? Oh, good idea. We can do the same by taking the maximum. So in this case, 1 and 2 are always together, but the distances from 1, 2, and the third is 3 or 4. So the maximum distance is 4, and that's the rule of my matrix. And I have my maximum. And I do the same. The smallest then is at the level 3 between object 4 and object 5. I've put them together, and I compute my distances. And I have the result of that, which is called the complete linkage. And this is another solution that we can take by taking the maximum distances rather than the minimum distances. Okay. But you can say, of course, why to take the minimum, why to take the maximum, or why not to take the mean value, or another measure between that? And in fact, that was the tradition And the statistician have discussed that in length, saying, okay, in some cases, it's good to take the minimum, so the single linkage. In other cases, it's good to take the complete linkage, so the maximum. In some cases, it's good to take the mean. It could be too good to take the median. It could be good to take another criteria. Or even there is an idea of a flexible method I will show in more detail later. That is with a parameter that we can play in between the minimum and the maximum. But once again, as a user, it's a little bit complicated because we never know which is the best way to use. Do we want to use the minimum? Do we want to use the maximum? Or do we have to use something in between? Most often you will see that it will be the word method, which is the criteria to put together two groups or two units that increase the less the amount of variance in the structure. And this is rather tricky in order to know exactly which method to use and on which condition. And I will try to show you some example for that, but for that I will try to switch. Okay. So everybody can see the example, it's okay? So the first example, all these examples are taken from a beautiful book from Brilliant Everett that is called Cluster Analysis, which is really a nice introduction to this kind of story. And this book is also fascinating. I will mention it later, but because there was 5 different editions of the books. The first one in 74 was really introduction, and the last one with other colleagues in 2011 is more discussion about more complex cases and so on. But it's really a very easy, very gentle introduction, which is very interesting to use. So if you look to my example there, you see that you have some points which are in red, the upper right corner, and some points which are in black in the other corner. In fact, that 2 distributions that were generated with different parameters. And the question will be, which method will be good in order to recover this structure? So if we use the word method, which is on a criteria on variance, you see from the diagram that we will find at the end 2 groups. And you see that these 2 groups are rather good. So the triangle are the group 1 of word, and the circle are the group 2 of word. And you see that all the triangle are red, and all the black are circle. So that means that the method works perfectly on this dataset. So far, so good. On this kind of structure, word is perfect. If on the same data, I use the single linkage, so the idea to take the minimum distances that I have shown you as the first cases, you see that probably it's hard to see 2 groups. You have 2 points alone, and then all the points are put together and so on. So probably it's not good. And if I look, oh, what I've done. Yeah, that means that you will see that there that more or less all the points are circles. So that means that the single linkage is not a good solution for this case. Okay. For the complete linkage, so the idea to take the maximum distance, you will see that we will find 2 groups, and you see that the 2 groups are good. So in such a case where 2 circles, either the complete linkage is good, either the word method is good, then the single linkage is not good. But if we take this structure, you see we have the group of the red, which are lined in the upper part, and more or less the black ones, which are also along an ellipse in the lower side. What happens if we take the word methods? You see that the idea of two groups is probably not perfect. According to this, we have more the impression that there's three or more groups than two. And if you look there, you see that we have circles on the right and we have triangles on the left. So that means that in such a case, the word method will try to have one circle or one ellipse to the right, one circle or one ellipse to the left, but is not able to find the structure of the two ellipses that we have at the beginning. To say, but for the single linkage, if we take three groups, because there is one which is just alone, you see that we have the circle which are correctly identified, and we have the triangles, the red triangles, which are correctly identified. So that means that in this case, the single linkage is the good method to use, and the complete linkage or the word method is not the good method. And in fact, the explanation of that is when you take as a distance the minimum, you will just look to the closer point and you go from the close to the close to the close, so you do some chain. And if the distance between groups is greater than the distance inside the groups, then the idea to take the minimum is a good idea, the single linkage. But if in the case of word, in fact, as you use a variance criteria, you will try the variance to have circles. And if you used variance-based criteria, you will end up with clusters which are circles rather than ellipsoid, that is in this case. So that means that the choice of the method that you have is probably very important, because in some cases you will have good solution for one method but not the other. And for other cases, you have a good result for one method, for the other method, and not for the first one. So it's really complicated to know, because, of course, in the case that's easy, because I fabricated this example in order to show you this example. And I have produced this example in two variable setting. So that means that's easy to have the representation in a plane with these two variables. If you make an analysis with 20 variables, in fact, you are in a space with 20 dimensions, and you have no more ideas about what is going on. If you have ellipsoid that you can find with a single linkage, or if you have circles or hypercircles that you can find with one method or the criteria. And this is one of the problems that you have with cluster analysis, meaning that the structure of the data at the beginning can change a lot of things at the end of the analysis, even if you have no idea which is the structure of the data at the beginning. So that's part of the story. In the same line, I can show you so that's I had the third example. Yes. Okay. So if I take this example with the black, which are like an ellipse, and the red, which are more like a circle, you will have more or less the same type. So the word method is give two groups. The two groups are more or less correct with some superposition in the middle. But as the groups are closed, we can suspect that the single linkage, so the minimum method, will not be so good in order to have a solution. And you see effectively that you have not a good discrimination between the two groups, the black and the red in such a case. You see that, yes, single, that it's a little bit complicated, but with 3 groups, you have a group in the middle, you have some confusion here, and it's a little bit complicated to find a good structure with a single linkage because you have these points which are close together. And the complete linkage is not good at all in this case because you have just a triangle at the top right and a mix between the circles and black and red in the lower part there. So that's okay. So that's my example for that. So that's really a problem that we have, that the solution is really depending on the structure of the data. And in some cases, one method could be very good. In some other cases, which are not so good. And yes, I had other example that I forgot, but doesn't matter. In fact, what you can do is to use a mix of methods. And if you have the same result between different methods, then probably you can be rather confident about what you have. But if the results are very different, then you must be a little bit careful and try to know more about the structure of the data and what happens. So that's the first rule, okay? And then there is another problems with these methods. And this is, okay, if I go back to this, you see that in fact we develop a tree that goes from the points which are all isolated, and then step by step we put the point together. And we cut the tree at a given level in order to have 2 groups, 3 groups, and so on. Okay? But in fact, for a classification point of view, we are not doing the best classification at the current level that is possible to have, but we are optimizing the path. We are optimizing the logic of going to all element isolated to all element together. And so that's because what we have at level 3 or the third grouping, you never change that what was before and what is after. So at each level, you have a grouping. And so you are really doing the best possible path from every cluster separated to one cluster that take everybody together. But you are not doing the best classification at a given level. And that's really a problem. So that means that the hierarchical analysis, all this analysis that goes from all isolated to one together, are called hierarchical analysis, which do these beautiful trees that you have seen in a lot of publications. In fact, they are very good with a sensibility to the structure of the data. They are easy to read, but they optimize the path, not the classification. And even with modern computers, you have some limitation. For example, I will show you after an example with 30,000 observations. And if you do this with 30,000 operations, you have a matrix of 30,000 by 30,000. That's mean 100 millions of data. And in the memory of the computer, 100 millions is a little big. So normally you have to do something in order to reduce the information of the number of points. So probably that's not the best solution. At the same time, if I have taken 15 minutes to present this for you, probably it is useful nevertheless. I will try to explain why it is nevertheless useful to have this approach. But in general, it's not the solution by itself. You have to use also other things in order to have the solution. Okay? So, what is this other thing? About that's easy. that's the idea, to have what we call a non-hierarchical, so the best solution at a given number of clusters. So that is what we call k-means or partitioning techniques. So that means we want to have the best possible classification at, for example, 5 clusters or 6 clusters or 2 clusters. So to find really the best classification at a given level. We will see that one of the problems is to know how many clusters I have in my data, because my k-means will give the solution at a given level, but I have no idea if 4 or 5 or 6 is the good number of clusters to keep. So I will have to find some solution in order to do that. Okay? But more technically, how it is possible to find a partition in my data at a given level. In fact, I have 3 steps in this analysis, and more or less all these analyses are doing the same type of job. See it like this, it's very trivial. In fact, it's a little bit more complicating. The first step is to find a starting configuration. If I want to have, for example, a classification with 6 clusters, I need to have the first centers of the 6 clusters. So I need to have this first configuration in one way to another. Then there's another steps which can be repeated, where I take the other points or the data that I have, I compute the distance to these centers, and I allocate my unit to the nearest one. Okay? So I have 6 centers. I take a point, which is the nearest one. Oh, it's the center of the group 3. Okay, I put it in the group 3, and so on. And normally I have to do some reallocation, because when I add the point to a group, the center of my group can change. And then I have to repeat the operation in order to say, with this new center, what happens? Is it still the nearest one? And so on. So it's just a combination of allocation of the units to the different groups, recomputing the means, reallocating, and so on. So that's the idea. Once again, the idea is rather easy to follow. The problems that I have with that is, first, as I have mentioned, how to find the good number of clusters. Must I have a solution with 2, with 3, with 4? I will take a little bit more. I will speak a little bit more on this later. And the second is how to find the start. How to find the first centers of the clusters. For example, the first algorithm that was doing this was taking the first 3 or 4 or 5 points in the data sets in order to define the first centers. Of course, very often it's not a good idea, because in the data sets you have some elements that make that the first elements are not the same as the last one. For example, they come from the same geographical unit. For example, that was the first to answer to the questionnaire, and so on. So probably these first points are more similar than the others. Okay, so that's not a good idea. The second idea was to have a random selection. So I will at random take the first point, the second center, and so on. Very good. But once again, if you are lucky, you have the most different points and everything is fine. But if you are not lucky, you have the most similar points, and then you will be in trouble after that in order to do the allocation. So there is a lot of different systems in order to find these points, but very often it's not so clearly described in the algorithm. And probably a better solution is to think a little bit more, which could be the best solution. So for myself, what I do most often, and I will show you that in more details later, in order to find the starting points, why not to do a hierarchical analysis? because probably even if the hierarchical analysis is not perfect, it will give you an indication about different groups. So probably that's the way that you. The second point, yeah. The second point is also probably to do different analysis. If you have always the same results, probably it will be stable results, so you will be happy. If you have results which are very different from one analysis to the other, then probably you are in trouble because the structure of the data is not so clear, and it will not be a good result because it is unstable and just by random fact that you have this result or another one. And for that, I have to do a little parenthesis that if we do a cluster analysis, we will always have a result, but it's not clear that the result is a good result in this sense. So it's a stable one. So you must be a little bit careful because at the end, you will always have a classification variable, but you are not sure that there is a real structure in the data and you are able to find a good structure in the data. So that's why it is important to do different analyses and to see if they are very different, then you will be a little bit more careful than if you have a really stable result. So that's the point. The other point that is important to mention is when you use as a criteria the distance, the geographical distance, you will tend to look for circles because you go from the center and you look to the points which are the nearest one in sense of distance. So you will tend to have clusters, circles as results. So if you think at the first example that I've given to you, when you have two groups which are circles, it will be very good. If you have two ellipses, then as in the WARS solution, you will have two circles and the result will not be so good. So once again, the structure of the data is important to think a little bit, and it will be important for the result. In some case, it's good to have circles as results or circular or spheres as the clusters. In other case, it will be totally inappropriate if the data have not distribution, multivariate distribution, more like ellipse than circles. So that's also an interest to vary the scales of the variables in order to know what happens, or to have really a reflection about what is the scale of my variables and how can I measure them in order to look at this. Okay. So I can then switch to a real example. My example is not good for a publication. The results are not good enough, so I will not do a real paper with this data. But I wanted to show you an example that I think it's interesting because it shows a lot of the problems that we have with this kind of analysis. So some of you knows the ISSP, this beautiful project in many different countries. And in the ISSP 2007, the module about leisure and sport. And the first question of this module was in fact a battery saying, oh, how often do you do each of the following activities in your free time? And the categories of answer was daily, several times a week, several times a month, several times a year or less often, or never. And then yes, I will come back to this later. The name of the book that I have mentioned, I will put in the bibliography. That's Cluster Analysis. I don't know if you can read it. Cluster Analysis by Brian Everett. I will put it in the bibliography also later. Oh, I can. cluster analysis. Again, evaluate. Okay. So if I go back to my example, the activities that were proposed was watch TV, go to movies, go out to shopping, read books, attend cultural events, get together with relatives, and so on, until spend time on the internet. So you have a classical battery of 13 activities, and come on, oh yes. Okay, yes. Okay, with the scale going from 1 to 5. And of course, the question is, thank you, Claire. The question is, can I do a cluster analysis of these variables? And what can I expect? From a theoretical point of view, I can say, okay, probably yes, because I will have very active people and not active people, or I will have people that have eyebrow activities like books, concert, and so on, and other ones that are more in the relation with others, some which are more linked to relatives, some more linked to friends. So probably I have some groups that I can find from this data. And it's interesting to do that in different countries, because in Western Europe, perhaps I will have another structure than in South America, and so on. So that's a good idea to try to test, to do a cluster analysis on this set of variables. But is it a good idea to take it directly 1, 2, 3, 4, 5 as the metric for this kind of analysis? Oh, then I don't know, because in these variables, I have the same distances between daily and several times a week, then between several times a year and never. So probably I have a problem with the metric if I take directly this as an input of my analysis. The first idea that we can have, so I can do a lot of different things. If I use the original variables, I can use, as I mentioned, the original values. So 1, 2, 3, 4, 5. Okay, why not? I'm not sure that is the best one. I can try to rescale these variables as frequency. So to say, okay, one is done 300 times a year. Each day it's 300 times a year. Once a month is 10 times a year. So to have a recodification going from 300 to 0, which is the real never. Or I will also show you later, I can do a kind of factor analysis of these variables to see if there are some dimension in this, and use the factor scores, because the factor scores, the correlation that is used for computing factor scores, in fact, I am scaling the correlation by not considering the mean and just standard deviation. And the basis for correlation coefficient is to compute similarities between variables or covariance, taking out the mean and controlling by the standard distribution of the variables. So I will show you two examples. One, which is a little bit strange, but nevertheless, which is the idea to rescale the original value as frequencies. So to say each day is 300, once a year is 1, and so on. And the second solution is to use factor scores, but it will be a little bit special factor scores. I will show you also this possibility. Okay? So, the solution that I propose is the following. First, it is impossible to do a hierarchical analysis with 30,000 cases. So I will probably begin with a non-hierarchical, but a non-hierarchical with a big number of clusters, in the case 20. Then I will do a hierarchical analysis from this 20 to completely together. That will give me some indication about the structure of the data. Then I can decide the number of clusters that I want to keep. I will show you that there is different solution. And from that, I can use the result of the hierarchical analysis as the basis for reallocation. And then I can try to interpret the different results. Okay? So that's the hierarchy with a subset of 1000, which is not a good solution. Then you have the R code that produce this kind of thing. You will have the R code in the slides. And then you have the representation of the hierarchical analysis going from 20 clusters to all the clusters together. And in the case I have used the word method, and you see that it could be a solution, it could be reasonable to decide to keep 6 groups. That's the red groups that I have. Why not? I have another indication for that. I can try to make, like in factor analysis, in factor analysis, you have the scree test, which is the proportion of variance according the number of factors. I can do the same, and I can compute the explained variance in each solution. And you see in the case that I have a difference in the graphic at the side of 6 clusters, that could be an indication that 6 cluster is not so bad. Okay. And if I do that, I have the 6 groups, and I have choose a very easy representation. If the mean of the group is very different of the mean of the variable, then I put a lot of plus. If it is really smaller than the mean of the group, then I put a minus, and so on. And you see that you have a solution with that, where, for example, the group 4 is reading a lot of books very often. The group 2 is a lot of exchanges with the relatives. The 6, a lot of exchanges with friends. The group 5 is defined by heavy use of internet, and so on. So that's a possibility, is to use these metrics to end up with 6 groups and to have this interpretation of the groups. Okay. At the same time, I don't know if you are all totally convinced that the measure that I have used is the good one. Because if you look at the television every day, and most people are looking to the TV every day, more or less everybody will have high score on television, and so television will have some impact in the classification. Why an activity which is going to concert, of course, nobody is doing that every day. So in fact, the scores of concert will be very lower than the score of television, and have less importance in the solution. So probably this way to compute groups could be a solution, but I'm not sure that it is really the most interesting way to do that. Because you have a big impact of the scale of the variable, and the scale of the variable will be very different from an activity that you do daily from one that you do much less often. So an idea could be to do a factor analysis and to take the scores of this factor analysis, and then from these factor scores, you can compute some variables in order to do the analysis. And from this, do the cluster analysis on the basis of the factor scores rather than on the basis of the original variables. That means that you have, in fact, a scaling, in fact, a kind of standardization that you have on the original variables through the use of the factor analysis. Okay? Now, you can add one more point. You can say, oh, my variables are ordinal variables. So is it good to compute normal Pearson coefficient, correlation coefficient, when you have ordinal variables? Of course, we do that every day. And there's a lot of publication which do some principal component analysis on the basis of ordinal variable. So why not? But you can say, okay, but we have also some techniques that we can use. And in particular, we have the nonlinear principal component analysis that will try to do some scaling of the original values in order to keep the information about ordinality, but at the same time, we'll try to reorder the categories in a way which is better statistical term than the analysis. I will show you a little bit later. You can also, in some cases, go one step further and say, why not to do a correspondence analysis? So if your variables are nominal, you can do some correspondence analysis, and from that, use the scores of the correspondence analysis as the input for the classification part, for the typology, for the clustering techniques. And in this case, you have no problem to compute Euclidean distance because you have already transformed the original variables into some continuous, some internal variables, which are the scores of the correspondence analysis. And I like this very much because, in fact, you have two different schools for that. I do a little excursus, but nevertheless, you have two different schools. Normally, the correspondence analysis is used by the French school, and it was the Bazekri school and colleagues after that, Lebar and so on, that use systematically correspondence analysis. I've linked from the beginning correspondence analysis to classification analysis, doing systematically some correspondence analysis in order to do after that the clustering methods. But there was also another school, which was the Dutch one, with people like Jan de Leeuw, that they wrote a beautiful book, which is called Giphy. And the Giphy methods are a way to generalize the multivariate analysis. In fact, saying that correspondence analysis is like nonlinear principal component analysis, where you do just some rescaling of the original variables, and with a different rescaling in the case of correspondence analysis on each dimension. Or if it is just on ordinal variables, you will do just one rescaling on the first dimension, and it will be okay in order to have this kind of rescaling. And in fact, what we do is to try to find a method that gives us the metric which is underlying the variables. And if we are able to find this metric, we can use it in the different analyses. And with the recoding, we can use directly in the principal component analysis. And for example, in this case, you can see that I was able to do some rescaling of my original variables. For example, for internet, which is the latest one, the category never is different of the other categories, but there is not so much in terms of scaling between once a week, once a month. That's the access to internet, which is important. The same for the match, so to see sports as a spectator. The difference is between people that never go to see a competition and the people that go more regularly. At the contrary, relation between relative or friends, it's more ordinal, keeping the logic of the original variable. So we have different logic in these cases. In some cases, we have a rescaling that change a little bit. In other cases, that change not so much from the original set. If it is a diagonal, like in relatives, it doesn't not change so much the original scaling. If it is the case of internet, okay, that's the reverse. And then you have a difference between sometimes and never, but not so many between the different category of sometimes, and so on. So that's mean that you can transform your variables. And in my case, it was ordinal variables. So that's the rescaling that I've chosen. But of course, it was nominal variables. I can transform them differently, have a scaling for each dimension, which is the scaling to use. And this is a way that you can use categorical variables as input for a cluster analysis after. Okay? So when we have done this kind of transformation, we can do a principal component analysis and use this the factor scores of the principal component analysis for the cluster analysis afterwards. Then there is a point you must be careful. Much of the programs of factor analysis and principal component analysis give you some factor scores, which is a mean of 0. Okay, that's fine. But the same variance, the same standard deviation of 1. So that means that when you take the factor scores out of the analysis, you will give the same importance to the last factor, which is really small in terms of variance, than to the first, which is much more important in terms of variance. So it's important to try to keep the scale and to modify the input variables by this scale in order to do this kind of analysis. So what gives you the size of a factor? But in fact, that's the eigenvalue. So you can multiply each score by the eigenvalue or the square root of the eigenvalue, just in order to have influence or dimension of this factor, which is more or less in the same line that it was for the original data. Otherwise, you will count much more the latest factor, which are not important, than the first one, which by definition are much more important in terms of variance. Okay? So from this point, we can take the same strategy as before and use these rescale analysis of rescale variables in order first. I don't have the in-between results, but doesn't matter. We can do the same. So first, a non-hierarchical analysis with, for example, 20 cases. From then, we can do a hierarchical analysis from 20 to 0 or to 1. Then to choose the number of clusters, in this case, I've chosen 6. And from these 6 clusters, do a reallocation in a non-hierarchy in order to have the final solution. And that's the result that I have had using the same type of presentation that I had before. So that's the basis for my interpretation. Now I have finished with the statistical part. That I can try to give a name to the cluster, or at least a definition of the groups. And from this definition of the group, I can try to use it. So how can I proceed from there? First point, you see that I explained 35% of the variance, which is okay, but not so much. So my solution is probably correct, is probably relatively meaningful, but it will be in any case not a scientific discovery. So that means that, okay, interesting as a summary, probably the other ways to do the analysis are more important. That's the first point. Second point, if I want to interpret my clusters, I see my 6 groups, which could be the line, what I have in my toolbox in order to do this kind of interpretation. I can say, okay, I have probably one dimension, which is the number of activities or the number of things that the people are doing. So if I am old and alone, probably I will have not so much activities, except perhaps looking to the TV. At the contrary, if I am 20 years old, doing a lot of sport and going to movies with the friends and so on, I will have much more activities. So probably one of the dimensions is to have activities or not to have. And in fact, you see that it is a dimension that is important in my table. Probably in group 4, you have far less activities. So that's the people which are less active than the others. And in the group 2, I have a lot of plus. That means that's the group which are active, doing a lot of different things and so on. So this, from the theory, I know that I can have one dimension which is important, which is just the frequency. And in fact, I have 2 groups or different groups where I have this frequency dimension that can appear. Okay? What else? Oh, I can say, probably in this kind of activities, I have eyebrow activities. So the activities like book, going to concerts and so on, which are a little bit holistic, and other one which are more popular, less eyebrow, less mark. So in this, I am a little bit in a Bourdieusian, like Pierre Bourdieu. So by specification of the eyebrow elitist activity versus less elitist activities, to say the thing like that. And I see that, in fact, I have probably that in my data too. You see that, for example, the group 1, it's much more plus for movies, books, concerts than the other groups, as well as internet use. So probably this kind of more elitist activities are probably more frequent in this group 1 than it is in the other groups. And I have, by contrast, the group 5, I have less books, even if it is less marked. So that's a way to make the interpretation. And another line of interpretation could be, in an urban environment, I have a lot of opportunities to make activities like shopping, like go to movies and so on, while in more rural environment, I will have less opportunities of this kind of activities. And it's probably the difference between the group 6 and the other ones. So you see that with these 3 dimensions, I have something like some lines of interpretation that allow me to interpret the groups. And I think it's really important to try to think a little bit which are the sociological mechanisms or the political mechanisms that explain why people have different set of preferences or set of yes. The group 4 is, you have only, first, it's the biggest one because he has 13,000 people, which is much more than the other one. So probably it's a group which is not so far from the mean, just because it's the biggest one. That's a result that we have often. It's a group which is more or less near the mean, so not so well characterized. That's one thing. The other points that make the group 4 is that you have only some minus. So that's mean that probably that's the group which is less active than the others. So it's defined not so strongly, but more than the others by doing less often than the others the activities. So it's probably a group that is generally less active than the other ones. And I will define it as a less active group, to say the thing like that. Do I answer to the question? Yes. Okay. So that's the point of interpretation that I have. The important point is, even if I was probably not totally convincing, that you need some theory about what explain the cultural behavior, the leisure behaviors. And this goes between age, between situation, between urban and, or it could be general activity, or it could be this Bourdieu perspective about eyebrow and not eyebrow activities, and so on. And it's because I have this background that I am able to do this kind of interpretation. And I think that's also a very important part of the activity, to do this kind of thing. By contrast, perhaps some of you, yes, have some memory of the work of Bernard Cattelan. It was in French, but also translated into English. It was about style de vie, which means lifestyle. And it does also, it was 20 years ago, a lot of different analysis in order to distinguish between different lifestyles. And he has not really a theory about lifestyles, but it was much more important for marketing to differentiate segments in the population and just to address differently to these segments. And for myself, it's a little bit disappointing because you don't know what these lifestyles are representing of. You don't know how to call them except Y, X, or I don't know which letter, but it's just description, and you have no idea about the importance of this group in a more general representation of the society. And I think if you want to end up a cluster analysis with some meaningful result, it's very important in order to make something about the analysis, to have at least some lines about the theory or some guidelines in order to interpret the result in little bit in terms of a sociological dimension or political dimensions, which are important in this direction. So if I go to my main conclusion, cluster analysis is really a powerful tool because to end up with a classification and represent to the public this classification, saying, okay, in all my data, I can say that this kind of behavior is summarized by these different ideal cases. It's really interesting. And it's easy to communicate. At the same time, I try to show with my example that sometimes the results are a little bit unstable, and you must be very careful in order to presenting this result. In fact, you have a lot of decision Do I take this method or this method? Do I combine this with this one or this one? How do I measure the variables? Do I use factor scores which are more robust at the end than just original scaling, and so on. And all these steps must be really discussed because they have really important consequences at the end for discussion. So there must be really thinking about the scales and the way that the variables that you use are measured. And if you use the original variables, the analysis is much more sensible than in the case of principal component analysis, because in the case of principal component analysis, the correlation coefficient that you use always take out the mean and put the same scale to the variables just by thinking about standard deviation. So, and if you take the original measure, then you must be a little bit more careful. At the reverse, if you systematically normalize the variables, and some researchers do that, you give the same importance to all the variables. And once again, that's not necessarily the best solution. If you have some variables which are linked, then you count 2 times or 3 times these variables by comparison to the others. So probably the best solution is this kind of mixed mode strategy, if I can say, mixed strategy, using as well dimensional analysis as purely cluster analysis, and in cluster analysis using a mix of hierarchy and non-hierarchy analysis. And so I think that's the best combination that I can use. The last point, which is important too, very often at the end you have a classification, which is like a nominal variable, and you don't have the relation between the categories. In fact, in the typology, 2 groups can be really close, and 2 other groups can be really far away. So when you do the interpretation, to try to have a representation, for example, in a map of a factor analysis, is also interesting because you will see which are the groups which are different but nevertheless close, and which are the groups which are different and really different in terms of dimensionality. So I will really give the idea to try to combine the different approaches in order to have some meaningful result. And the last point that I think it's really important is what I've tried to explain to you is this mix between the theory and the result. A result of a cluster analysis must be also meaningful in terms of theory or the representation that you have a process in order to be really communicated. And just to give letters in order to describe the clusters like A, B, C, D is probably not enough in order to make a contribution to the analysis. Okay, that was more or less what I wanted to mention, going from the beginning and the importance of the technical side and what is linked to the scale of the variables, to a more general strategy which try to put together the different facets. And once again, the idea of scaling that we can have through correspondence analysis, nonlinear, and so on, is probably one of the best solutions that we can have if we try to play with these kind of methods.
Thanks a lot, Dominique. It was very complete. I myself teach some classification analysis and I learned something in your presentation, so I'm very happy. Before I give I let people ask questions. First, if you want to ask question, be sure you can send to host and panelists or send to everybody. So be sure that you send to everybody so that everybody see your question. Second, if you want to speak, you ask your question verbally, you just have to raise your hand and I will be able to give you the possibility to speak. Before we go there, I wanted to show this. Wait a minute. Yes, I wanted to show. Wait a minute. Okay, this. Because there is a question of software. And R is very easy for people who took a lot of their time learning it. I just wanted people to know that you can go on DTM Vic. DTM Vic is a software that is free, and it does only correspondence analysis and cluster analysis, and also neural network. You see here that you have it in French, English, Spanish, Portuguese, and Italian. As for some of the information, the software itself is mostly in English. And you have, the software is rather easy to use, but Ludovic Lebar, Dominique spoke about him recently in his presentation, also put the Python language to do the same thing and the R language to do the same thing. So the input is a CSV file, but then you can do whatever you want, and I use it. It's rather easy to use. So this for the information. You also have a no, and it also does text analysis. So this for DTM Vic. Now, are there questions from the audience? If not, I just wanted to, in fact, Dominique, at the end, what you present is what we used to call the French school of analysis, in a way, that you use correspondence analysis, and then you use cluster analysis on the factor scores. And this is not very well known in outside of France, unfortunately, or outside of French-speaking people. Can you perhaps give us a bit of a, what is the advantage, the main advantage, and is it easy to use for like public opinion researchers, pollsters,
Yes. So there are different aspects in this. What sometimes I don't like, and I begin with the detour, what sometimes I don't like in the French school is that is presented as the way to do it. And very often the software, at least some French software, are just doing something which is always the same, which is correspondence analysis and then cluster analysis. And it's not always clear which are the details that are chosen, the technical details. So the way that I've chosen for you the presentation was to say, okay, I separate the different bits. And in fact, I have used no French software in this sense, but rather classical Anglo-Saxon or Dutch way to present things. That's the first thing. The second point, I think the traditions are not so far, and that's really important. To very often we have the impression that the French tradition and the Anglo-Saxon tradition are really different. If you go, if you say, for example, to do some cluster analysis just on the factor scores of a principal component analysis, is done by a lot of in the English tradition. It's not so complicated. Most of you know as well as me the principal component analysis, and so it's just a change in the scaling of the variables to use the principal components than to use the original variables. And in fact, the principal components if your original variables are interval variables, is just the same. It's the same amount of information. You do a principal component analysis with more or less all the factors. That means that you just do a rescaling, if you want, of your original variables. So it's not really different. It's really just changing a little bit the way that the variables are measured at the beginning for the technical security, or to have more stable, to eliminate some outliers by this kind of process. So until that's more or less the same. Where it is a little bit different is in the term of scaling. So very often we use ordinal variables as input for principal component analysis. So that means that we say, okay, ordinal interval, that's more or less the same. And it's true that it doesn't change so much. But at the same time, if we have special methods to check the ordinality and to check which is the nature of the scaling behind that just all benefits for the analysis. And what I like very much in the Giphy approach, so the approach of Jan de Leeuw, is in fact that you have a continuum between correspondence analysis and principal component analysis. It's just some variation in the model according to the way that you let the variables being different in terms of scaling on each dimension. So in fact, we are in the same world. And sometimes I am not so happy to see the opposition between the French tradition and the Anglo-Saxon tradition, because I think the opposition are too strong. And in fact, it's more or less the same world, but different ways to present them. So it's why I've tried to follow the logic of presentation of today. First, saying, okay, we go from the original variables. Then we can do principal components. Then we can do some scaling on the principal components. And we see that we are just trying to play a little bit with the scaling. But the scale is really important in order to have stable result from the cluster analysis. That's the point that I wanted to put forward. So, and also in the same line, when you take a new program, and that's a problem with R, that's true, but also with SPSS in some way, you never know what the algorithm are really doing. And you have really to go a little bit, in French, on dit les mains dans le cambouis, so the hand in the oil, in the dirty things, in order to know which things the software are really doing. And there is a problem of documentation very often for that. It's not so easy to find. And what I wanted to try to show is that to have an idea of what the software is doing is important for the result that you will have at the end in order to communicate. So to try to have a little bit of attention of the dirty things, not only to the beautiful result that you have at the end.
Dominique, you have 4 questions, 5 questions. So can you take them and try to answer rather rapidly? And there is also this point by Alexander Polion about Weberian analysis. So perhaps take the questions before, because they are rather simple, and then perhaps take the point by Alexander Polion.
On my eyes, I have only the question
Q and R. You go see Q and R.
Okay.
Okay.
Q and R. Yes. Yes. Okay. Good. First question about sample size. That's rather easy. Yes and no. If you do a hierarchical analysis, yes, probably you will be in trouble with big samples, but you can always take a subsample and then do the analysis of the subsample and then some reallocation. So you find always solution in this sense. The same you have in a cluster package, some analysis developed by Rousseau, Kaufman and Rousseau, that allows you to play with very big samples. So the answer is, at the end, you have no limit, but in some routines, you have some limitation that you can always find some solution to play with, to say it very quickly. For
the 3 next question, I will repeat them because some people don't get them. The three next questions are about jumping from confirmatory analysis to factor analysis to exploratory analysis.
Yeah.
In short.
Okay. The confirmatory analysis in the world of cluster analysis is complicated. You have the latent class analysis as a model. I was not always convinced by the result of latent class analysis. Sometimes there is a lot of statistical hypotheses, sometimes difficult to interpret and so on. So I would be careful to be too much on the confirmatory side. There are some techniques that allow that. There are some way to do it, but I think what you can always do in a semi-confirmatory mode is to say, okay, I defined a solution from one country, for example, take it in another one, in other country, and compare the explained information by the structure for the country with the structure more ideal typic of the other country. And then you have an idea of the loss of information if you take a solution which is more general in a particular context, and you can do this kind of thing. You can do, in fact, do the same in factor analysis also. When you define ideal structure and you look from a geometrical point of view, the difference between what you have when you do the best analysis possible in the country and when you do the comparison with the other structure. So there is a lot of ideas that we can play where we are semi-confirmatory, to say something like that. But really, if you are in a context where you must do some confirmatory analysis, then you have to explore either the techniques that allow that, either to try to choose other methods in order to do it, to say something like that. There are some ways, but it's really tricky, and sometimes a lot of hypotheses are needed in order to do it properly. So
Dominique, you have in the discussion this time, you know, if you go to discussion, Alexander is speaking about ideal types from Weber, the Weberian versus Durkheimian analysis, as I used to teach it. So the relationship, if you read it, and
so I wonder about the relationship between the Weberian ideal type, which is an emic category of social actors, and the rather latent of statistical type emic. And I have the feeling that the choice of linkage plays a role in capturing this. Yes. Without using emic and categorization, we can answer there are a little bit of duality when you do this kind of cluster analysis. In fact, what you have in mind as a researchers is, of course, something which is ideal typic. And so you build something which is in the side of the possible ideal types that you will have at the end of the analysis. And what you have from the data is some grouping that sometimes are in line with your ideal tips on the theoretical level, sometimes not. If it's in line, so you are really happy because you have a key in order to describe the classification, to describe the result. If not, it's a little bit complicated because you do not have confirmation, you do not find the ideal type in a way that you can play with. And so that's really, in this sense, there is a duality, there is a tension between the statistical result that you have and the interpretation that you want to give to. And of course, a good classification in this sense is ideal typic. The description of the typology, the way that the concepts are interrelated by the description and so on, that's really something which is ideal typic by definition. What you do by looking to the figures to the result, then it's a little bit more complicated. Or sometimes you can try to play with the distances on the statistical side until you will find back the ideal typic dimension that you expect to find. I think it's not really fair because probably something happens there. That means that you have some instability in the data and you have to ask if your theoretical model is really adapted to the description that you want to give. But I think there is really, you're right. The main difficulty is in the tension between the theoretical dimension that you have in mind and the description that you want to give of the result that you obtain.
Thanks a lot. I think this is the end. I will send here to everybody a link to because there is Lucia asking about concrete example, for example, in electoral preferences. What I have, it's an article that I wrote with my student, global problem for a global movement. It is a cluster analysis of leaders of green groups, ecologist group in Quebec and Costa Rica. So you should. It's been published in Nature, Society and Natural Resources. So and it's in English. So perhaps it could be interesting to some people here.
Yeah.
So
there is a last question.
Yes.
By
Yes.
Dan, which is an interesting one.
Yeah.
Is can you use cluster analysis in comparing two data sets from different periods? Like one to identify a structure and the other to compare to it. And the answer is yes, which is difficult with cluster analysis. If you do two independent cluster analyses, you have no idea of why always it's an ideal solution for itself. So that's probably the best solution in each case. And the comparison between both is really difficult because you have no idea about which is a local optimum, to say things like that, and the correspondence to the other. So what you can do is to use one structure as a reference and to try to compute the distance of each point to the reference and compare what you have as information in such a case with the analysis of the data by itself. So you see which is the distance that you have if you consider a common structure of the two data sets in comparison to the optimal analysis of each one. And then you have an idea on how to compare. And this is really important to the same if you suppose that different countries you have different structure or not, you can do the same. You can do one analysis by country and try to see how different are the result of each country from the other one. And then to recompute a distance between each solution and a common space or something like that. And I think this is really important for comparative analysis. And this is also important if you do some comparison in time. So.
Thanks a lot, Dominique. It's we're close to the end. I just want to first tell everybody the upcoming webinar topics: public opinion research in North Africa and West Asia. This should be in end of January, beginning of February, and the second one, the state of democracy in the world. And thank you to everybody. Thank you for staying to the end. And thank you, Dominique. It was extremely, how do you say that in English? Interesting, and I learned a lot. So, and I'm sure people learned a lot. So thank you very much, and see you, everybody. Have beautiful holidays in security with your friends and relatives, and see you in January for the next webinar. Thanks a lot.
Thanks. Thank you, everybody. Bye-bye.
Merci, Dominique.